Well, hello, pre-calcers. It is that time. I know it's your favorite time of the day, math education time. I know it's my favorite time of the day. Right up front, I'm going to go ahead and apologize for my voice. I have not picked up a smoking habit while stuck at home. No, unfortunately, the Rona has gotten a hold of me, and it decided to take my voice with it. But we do our best to look past that and learn anyway. Oh, by the way, I do need you to appreciate how difficult it is to make this video because my voice is sore. That's how much I like you guys. Anywho, all right. So, section 1.1, modeling and equation solving. Going to officially start pre-calculus today with chapter 1 of our textbook. And actually, we'll start with good old review. So the first thing we're going to do is we're going to find all of the solutions for this equation, basically. And essentially, when you're trying to solve algebraically, you're going to hope that factoring is going to work. I'll go ahead and tell you, spoiler, it works for this one. In order to make factoring work, what we need to do is bring everything over to one side. I like my leading coefficient to be positive. That way I don't have to divide by any negatives. So I will subtract 11x squared and 10x from both sides. So now I have 6x to the third, not squared, third, that's a 3, minus 11x squared, minus 10x equaling 0. There we go. Okay, the very first step in every single solving by factoring question is the same. Look to see if there's a GCF. And this time there does happen to be a GCF because all three of these terms have x in them, which means I could factor that x out to the front. There is no numeric GCF, so just x. I do want to bring up one thing though. Anytime this leading coefficient is negative, I want you to pretend that there is a negative GCF, even if that negative GCF happens to be -1. But this time, neither of those things has happened, so the GCF will just be x, like I said. When you factor out an x, it's technically a form of division. So we're dividing 6x to the third by x. That will give us 6x squared. Essentially, we took one of our three x's. Dividing it from here leaves me 11x, again, taking one of the x's out. And then for this one, we took its only x, so minus 10. There. This quadratic will factor using my favorite method, the Lizzie method, where a is 6, b is -11, and c is -10. In order to use the Lizzie method, like I've shown you before, you're going to need to figure out which two numbers multiply to a times c. For us, that's 6 and -10, so -60. And we need the two numbers we find to add to our b value, and our b value is -11. Okay. Now, it would be great if you could instantly see which two it is, but not everybody can. Worst case scenario, you do have to go through all the numbers that go into 60. 1, 2, 3, 4, 5, 6, and then they go 10, 12, 15, 20, so on and so forth. And one of them has to be negative because it's the only way you're going to get to multiply two numbers to get a negative result. The two numbers that we're looking for are 4 and -15. They will multiply to -60 and add to -11. So we come back over here to the quadratic that we have, and we break it into two sets of parentheses with an x in the front of both. The two numbers we found, +4 and -15, they do belong in these parentheses, and no, it doesn't matter which one you write first, unimportant. But you do have to remember the over a step. That's what makes it the Lizzie method, where a is 6. So draw arrow like that and like that. Now we reduce our fractions. 4/6 reduces to 2/3. And 15/6, both those divisible by 3, will reduce to 5/2. Now, if we were just trying to factor, we wouldn't be finished here. The last step of the Lizzie method when factoring is to take any denominators that are left and scoot them in front of their x's. So this would say 3x plus 2, and this would say 2x minus 5. But since we're just solving for x, the Lizzie method shows us our solutions right here. All we have to do is figure out what would have made the insides equal 0. And more specifically, rather than just saying the insides, why don't we say everywhere there's an x, we have a solution. So we actually have 3 solutions. Anytime there's an x on the outside, I don't care what else is out there with it. If it's just an x out there, or a negative pi over 17x, it doesn't matter. You got an x on the outside, its solution is automatically 0. And for these, we could say whatever makes the inside equal 0, which means just switch the sign. So negative 2/3 and positive 5/2. Those will be your 3 solutions to that equation. Boom. So will every single question be able to be solved that easily by factoring? No, it won't. I mean, take this one for example. We've been told to solve it algebraically and graphically, and the reason why is because, well, you're going to need to know how to do things by hand algebraically, and when you go to calculus next year, you will need to know how to operate that graphing calculator, and you're going to see that it does a lot of great things for us. So after I solve this algebraically, I'm going to grab handy dandy technology, and I'll show you how to do it with a graphing calculator. No, you won't have access to your graphing calculator on the test, but it is still a skill that I need you to have. Okay, just like the last one. The only way that you can solve a polynomial by hand is if it's set equal to 0. So I will have to add 4x and subtract 10 from both sides. Be sure to put your resultant equation in standard form. That means in the correct order. Now we look to Lizzie, and we see if there are 2 numbers that multiply to negative 10 that add to 4. Yeah, there's not. Shame. Okay, well, when we can't solve by factoring, then we have to go to our buddy Quadratic Formula. Now, normally I'd sing for you. I think I've already sang the Quadratic Formula for you, but I got to be real with you. My singing voice right now is not very good. I know you're disappointed. Quadratic formula, x equals negative b plus or minus root b squared minus 4ac all over 2a. Where a is 1, b is 4, and c is negative 10. Whenever I substitute into the quadratic formula, I make sure to use parentheses. This way I don't goof up any negative signs or double negative signs. I just find that it makes it much more likely that there is a sign mistake. All right. B, 4. 4. A, 1. C, negative 10. And A, again, 1. There. Clean it up a little bit. Four squared is 16. And remember, whatever symbol sits in front of a number belongs to that number. So this is actually a negative 4. So you're finding the product of a negative 4, a 1, and a negative 10. Multiplying 2 negatives will give you a positive every single time. So that's going to give me plus 40. And all that is over 2. So 16 plus 40 is going to be 56. Life would have been fantastic if 56 were a perfect square, but it is not. So we are going to have to know how to reduce our radicals. It's okay. We reviewed that in our Chapter A material, I believe, or Chapter P. I can't remember. It was one of the two. The point is, we need to be able to figure out which perfect square we can divide 56 by. The only perfect square that will divide into 56 nicely is 4. It goes in 14 times. And now, square root of this 4 gets to come out. It's liberated because the square root of 4 is 2. And last step, figure out if you can reduce your fraction. And in order to reduce your fraction, you do need all three parts of this to be divisible by the same number. And as it turns out, yeah, all three of those are divisible by 2, so we divide all three of them by 2. That's going to leave me a 1 in the denominator, so I don't need to write divided by 1. I mean, I could, but I don't need to. Negative 2 plus or minus 1 root 14. Just a reminder, inside numbers do not get to play with outside numbers, so this 2 does not reduce this 14 in any way, shape, or form. That's it. Those are your two irrational solutions. So how would we have found them on the graphing calculator? I'm glad you asked. Oh, that's a horrible glare. Let's see if I can escape it. That'll do right there. Okay. You're not going to be able to see the buttons I push, though. That's going to be a problem. Well, I'll show you. I hit the on button. Hopefully I don't have to show you where that one is. All right, anyway, here's how we're going to do this. This does say an equation equals another equation. A concept that you're supposed to have learned in Algebra 1, and maybe you didn't, maybe you did, I'm not sure, is that when you are trying to figure out when one equation equals another, you're legitimately trying to find the points in space where those two graphs exist in the exact same place. The way we do that algebraically is set them equal to each other. But with graphing technology, we could just graph those two equations separate from one another and ask the calculator to show us where they crossed each other. All right. So first things first, we need to graph them both. They are both functions, so we're going to hit this y equals button right here. Y equals. Should have taken you here. If any of your three plots are highlighted in black, this is not going to work. If that has happened, if your calculator looks like that, just go up there and hit your enter key to turn it off. There. Anyway, my first equation is x squared. X is this button right here, variables. Boom. Squared is its own button. It exists right here, above the log button. There, x squared. The other equation is a straight line. Y equals 10 minus 4x. 1, 0, minus 4, and then again, the variable button, x. Now this button right here says graph, and this will take you to a graph. However, sometimes the last thing you graphed is going to have a jacked up window, and that means you're going to lose precious seconds or even minutes when you're on a test in the future, waiting for the calculator to stop graphing. That way you can correct your window. You should be in the habit, like I am, of before hitting graph, just immediately hitting this zoom button and then hitting the 6 button, because that will take you to a standard grid. That means 10 by 10. Just hit the number 6. And it's going to graph my parabola and my straight line. Okay, now the quadratic formula showed us there are two solutions. One of them is going to happen right there where those graphs touch. The other one has happened somewhere up here in space. So we're going to have to make our window larger. This button right here says window. Press it. The problem that we were having was that our graph wasn't tall enough. We needed a bigger y value up top. So x minimum is fine, x maximum is fine. That's far left, that's far right. This is showing you how far apart your tick marks are. 1, that's fine. Y minimum being negative 10, sure, whatever. It didn't really matter because, you know, our answers were up much higher than that. But this y maximum was an issue. Now look, that's a pretty steep line, and I honestly don't know how high up I need to go. So I'm just going to take a stab, and I'm just going to say 50, and I'm going to hope that 50 is way too big. 50. And then I'm going to scroll down to change that y scale. Why? Because the distance between negative 10 and 50 is 60. If I leave my y scale at 1, there will be 60 tick marks. That's a lot of tick marks, and that will slow the calculator down. So I typically just figure out the distance, which is 60, and then I divide by 10. That's just a me thing. You don't have to do that. Now hit graph, and let's hope it was big enough. There we go. It worked perfectly. So the viewing window that I chose did work very well. If yours didn't work on the first try, it's really not a big deal. Just go make it larger if you needed to, or if you made it way too big, then go in there and shrink it down again. Not a big deal. You may be wondering what that little blinking light is. It's because I paused the video and then had to restart it and I accidentally pressed a button. Don't worry about it. You don't need it. Anyway, we need to ask this calculator where these two graphs are crossing each other. We can see both answers. There's going to be one there and one there. Realize, please, that we're looking for the X values where that happens. So if you could figure out where that crosses and track it straight down, where that crosses and track it straight down to the x-axis, that's what we're hunting for. And this calculator can do that using that command right there, calc. Literally means calculate. We're going to ask this calculator to calculate for us. You couldn't see the hand gesture very well, you just saw the fingers, but we're going to ask this calculator to calculate for us where the intersection is. Now, because that says calc in blue letters, we need to hit this blue button to make it work. Second, calc. Now we're looking for the intersection of two graphs, so you could scroll down and hit enter, or you could just press the number 5. 5. Great. Now the calculator isn't aware how many different things we've graphed. For all it knows, you've got 30 graphs on there right now, so it has to legitimately ask you, well, which two graphs were you looking to figure out about? So it says, the one we're flashing on, is this the first one? You say yes by hitting the enter key. And then it says, well, is this the second one? You say yes again by hitting the enter key. And this is, okay, you want to take a guess where the answer is? What you do is you use your left and your right arrows to scroll over to where you think the answer is. I'm just going to go left. And I'm just going to hold it down. And you just get close. That's pretty close. And you hit enter again. And it says, oh, okay. One of the answers is at negative 5.74. That's negative 2 minus root 14. And if you want to find the other one, you do the exact same process. Second, calc 5, enter to tell it first curve, second curve, and then just hold down the right arrow until you get pretty darn close. And you go, that's close enough, enter. And it goes, oh, the other answer is at 1.74. That's negative 2 plus root 14. And there you have it. Graphically solving. Isn't technology wonderful? Second on, we'll shut your calculator off. So down here, we have a box that says fundamental connections, and I'm just going to shorthand it for you, okay? This box down here basically says when you're solving for x, you're finding roots, solutions, zeros, x-intercepts of a graph, and all these words mean the same thing. There, that's the fundamental connection. So if you're told to solve for x, find the intersections, find the root, find the solution of y equals f, all that stuff, it all means the same thing. It means solve for x. All right. Yay, word problems, everybody's favorite. I know. Try to contain your excitement. The engineers in an auto manufacturer pay students 8 cents per mile plus $25 per day to road test their new vehicles. That sounds awfully linear to me. How much did the auto manufacturer pay Sally to drive 440 miles in one day? Okay, well, luckily they said one day. Because if they didn't, we would have to be dealing with two variables changing, but right now we don't. So I'll tell you what we're going to do. We're going to write an equation, and let's see. Things based on miles, right? So let's let P of M be payment after M miles. There. That means we have a payment equation. The way we get paid per mile is a rate per mile, which is that 0.08, and dead giveaway is the word per, that was its slope, 0.08 m, and it even says plus 25 miles per day, but since we're talking about one day, I don't need to have a multiplier next to that. Back to part A. How much did Sally get paid to drive 440 miles? That's a number of miles. That's M. All we have to do is figure out the payment after 440. That literally means plug in 440. And then add 25. Grab a handy dandy calculator. You type it all up, and you will get 60.20. So Sally made just over 60 bucks that day driving around a car. Good for her. Part B. John earned $93 to test drive a car in one day. But this time we want to know, how far did he drive? So 93 is actually this value, the payment per mile, or payment in terms of miles, excuse me. So the 93 goes there, and we will solve for M. By doing some basic algebra. Let's subtract 25 from both sides. And I like my variables on the left, so hopefully no one will have a huge aneurysm. Then I'm going to write 0.08 m equals 68. And then divide. Again, grab a calculator. 68 divided by 0.08 is exactly 850 miles. There you have it. And our last example for section 1.1. Now this is labeled seeing grapher failure. This can really only be done if you have a graphing calculator. The whole point of this question is to show you that honestly you can be smarter than the technology. Because there's going to be times where the technology, I don't want to say lies, because it's not wrong. It's just that it's bound by its screen size. It's a pretty small screen. It can only show you so much. You might have to enhance. You might need to zoom in a little bit. So this says seeing grapher failure. It tells you to look at this graph in this window and say, are there any x-intercepts? This window is kind of strange, so I'll tell you what I'm going to do. I'm just going to change those numbers to -5 to 5 and -3 to 3. I don't know why they're so odd. So we go back into our calculator. I'm trying to get rid of the beaming lights. Where were you on the night of the 3rd? Okay, anyway, let's see. All right, on. Go back to y equals. You see I have those old graphs in there, so I'm going to hit clear for both of them. Okay, 3 minus. Now, this is a stacked fraction. I love this calculator because it has a stacked fraction option. Our math structures like radicals and fraction bars and things like that can be found in here in the math menu. So we press math, and up top there is literally a frac menu. So I'm going to scroll to the right, 1, 2, 3, 4, and the very first one says n over d. That means numerator over denominator. Hit enter, and look, we have a stacked fraction. So we press a 1 and then press the down arrow. Boink. Now we need a square root bar. Well, if you look on the left-hand side, right there above the x squared, there's a blue square root bar. So just like the calc menu, if you would like the blue things to work, you are going to have to hit the blue button. So you press second, then you hit that x squared button. Oh, look, a radical. Now we type x squared. X is our variable, x. And then the same key where we found our radical is the squared button. So we press squared, and then -1. And I'm not going to hit zoom 6. This time, I'm going to just go directly to window and type this, window. The assumption is that the first span of numbers is the x-axis. So we're going to go from -5, press the delete key to get rid of the 0, to +5. Scroll down to y minimum. Go -3, press delete to get rid of the 0, to +3. Now, just in case, when you're trying to type these numbers, this is not the negative symbol. That's minus. This is negative. And if you use a minus sign when you were supposed to use a negative sign, the calculator will give you an error message. It'll say syntax. Okay. Now that I've adjusted my window, ooh, make your Y scale 1 again. There you go. Now I'm going to hit this graph button, and we're going to see what happens. It says, are there any x-intercepts? Ooh, let's find out. Oh, hey, wait a darn minute. Focus camera. Focus. Those blue lines aren't touching that x-axis. So are there any x-intercepts? Well, our fundamental connections said that x-intercepts solutions could be found by setting the equation equal to 0 and solving for x. So let's give it a crack and see what happens. Alrighty, trying to get x by itself, but dagnabbit if x wasn't stuck in the bottom of a fraction. So what I'm going to do is I'm going to move the entire fraction to the right side. The reason why I'm doing this is because this will make it positive. Because right now it's negative and I don't like that. There. And, oh, I know how much everybody loves fractions. Psych. So what are you going to do? You're going to multiply both sides by the denominator. That makes fractions go away. So we'll multiply both sides of this equation by the square root of x squared minus 1. What that's going to do on the right side is cancel out. But on the left side, eek, we've got something ugly. 3 root x squared minus 1 equals 1. No, you cannot square both sides. Why, Mr. M? Because the square root bar is not alone. You can't cancel a structure until it's alone. So if we want to get rid of that radical, we're going to have to first get rid of this 3. This is a multiplication, so we will divide both sides by 3. Running out of vertical space, so I'm going to head over here. There. Now, we can cancel a square root with its inverse operation, which is squaring both sides. Remember your exponent rules. When you have a fraction raised to a power, this power gets applied to the numerator and the denominator. So this is 1 squared over 3 squared. When you cancel a square root with a square, it does not create a plus or minus. If you do it in the reverse order, if you cancel a square with a square root, that creates a plus or minus. So we didn't have to worry about it this time. Here we're going to need to add 1 to both sides. And that will give us x squared equals 1 and 1/9. Ew, yuck, a mixed number. Remember, multiply down, add straight up. 1 times 9 is 9, plus 1 is 10. And now, we take the square root of both sides. This, canceling a square with a square root, does create a plus or minus. Remember, a radical is an exponent. So here I have a fraction being raised to an exponent again. The same rule is going to apply. You make sure both the top and the bottom get that exponent. Square root of 10 is not pretty, so I'm going to leave it square root of 10. And square root of 9 is 3. Whoa! Algebra says there's 2 solutions, and there they are. So what was the problem? Why didn't the calculator show me solutions? Is it broken? No. It's bound by its programming. It can only show you so much. So I'm going to go back to graph. And what I'm going to tell you is, this calculator cannot graph vertical lines. And unfortunately, with the window we have, going through the x-axis there would force this grapher to graph something that appears to be vertical, and it can't do that. But if I were to shrink my y-axis, Say -1 to +1 and hit graph. Bet money we see it cross now. Eventually. Must be kidding me. It still didn't work. Okay, maybe the x-axis needs to be shrank too. How about -2 to +2? Stop making me a liar, calculator. See, I'm smart. There you guys. So now you know. Do not always blindly trust the calculator. You have a brain. Use it. Cool beans? Cool beans. Alrighty. I hope you guys enjoyed.